Alright, so welcome to the first chapter of the JC H2 Math syllabus. It's called Sequences and Series. But just as a caveat, right? Some JCs might follow a different order. So depending on which JC you go to, you might not study this chapter first, but this is definitely a chapter that you will learn in the first year in JC 1. So I'm just going to be following the sequence that I learned when I was in Hwa Chong. Okay, so the first thing we are going to do is to actually define a lot of important terms before we actually start getting into the formulas. Okay, so you can see that on this YouTube channel, this whole series is going to be many different parts, and that's why it's very important for us to make sure that our foundation is set in stone first. And the most basic thing to figure out in this whole entire chapter is what exactly is a sequence, right? And later on, I will actually talk about what is a series. So you just got to remember from this video, a sequence is basically an ordered set of numbers. Okay, so note that there are two keywords over here. The first being ordered and the second being set. So we know that the set, let's say I call the set S over here, right? Typically, it's denoted by the curly brackets like that, right? That's what you learn in EMath, right? Now, when we say ordered, means that there has to be some sort of ascending or descending order. Typically, each number, there is some sort of relationship between each number in the way that we actually arrange them. So an example would be, let's say 1, 2, 3, 4, 5, right? This is an ordered set of numbers because you know that there is a typical sequence that follows, right? Each number is a difference of 1 plus 1 plus 1 plus 1 plus 1, right? But then, of course, it also can be a case where it's a sequence that does not follow this specific relationship. And just for your information, later on we will be going into the specifics, but this is also what we know as your AP, right? Your arithmetic progression. But if it's your first time dealing with this chapter, don't need to worry about it. We'll go and define that a lot into more detail later, right? But GP is another type where the difference between each number is actually a constant multiple. So for instance, let's say I have 1, 2, 4, 8, 16. You can see that it's an ordered set of numbers as well, but now the difference is not a constant, right? It's a multiple. So that's what we call geometric progression, and the first one is called arithmetic progression. But later on, we will actually dive into that, right? But at the core of it, I just want you to understand from this video that a sequence is just an ordered set of numbers. That's all that you need to know. But before we actually move on, there are some symbols that you require to know. So now I'm just assuming that you already know everything already from your EMath basics in secondary school. Things like set notation, you should be rather familiar with them, right? What are some symbols that you need to know? Over here, right, in a sequence, typically we would usually write out a sequence in a set. So over here, this means a set. Alright, and later on in our example question over here, you can see that there is a set over here, right? And whenever you see a set symbol, it means that there is some sort of sequence over there, okay? And also, all of these terms in a sequence, right? This is the first term, this is the second term, this is the third term, this is the fourth term, this is the fifth term, right? They are all ordered. So since they are all ordered and they are related to each other in a specific relationship, they can all be modeled after this thing called the general term. So let's just use this example over here, right? You can see that the first term is 1, the second term is 2, and then the third term is 3, right? And then, of course, this goes on and on forever because we don't know whether this is an infinite sequence, right? Or whether it's a sequence that actually ends, right? We don't know. So we just assume that it goes all the way. So for the nth term, right? The nth term would be, look at the difference over here, right? It starts off at 1, and then you plus 1, then you plus 1. So at the nth term, it will basically be 1 plus n minus 1 over here. Or in other words, you can say that the n term is n, right? Because you realize that this number and this number is the same, this number and this number is the same, right? These two are the same and this number is the same. So there's some sort of pattern over here. And then the n term will be here, right? So the second thing to note from this is that every sequence has a general term. And usually the general term will denote it as Tn. So in this example over here, the Tn is very straightforward, right? The Tn is just n because the relationship is very clear. But later on, as we go through more examples, you realize that sometimes the general term may not be so clear, right? And that's where you need to actually go and figure out what the general term actually is. So all in all, this is the introduction to what a sequence is. If you got any questions, let me know in the comments below. And if you're a J1 student looking for a H2 Math tuition, come and get tutored by me personally. We'll master the number on top of the screen over here. If not, we will actually try out a question immediately to apply what you have just learned. So right now we're going to practice a very simple question. You can try it out if you're feeling confident, and I'm assuming that most watching this first time JC students, right? Or maybe secondary 4 students who are looking to go into JC. Based on whatever you have went through just now, you should be able to make some sense out of this question over here. So feel free to pause this video right now to type the question, and I'm going to be just jumping right into this So yeah, hopefully you're done by now. Okay, so let's just jump right into this. So let's break down the question. We have a sequence and it's given by un. So just note that un over here is the general term. And we know that the general term is n squared, right? That means u1 would be 1 squared, right? Which gives me 1. Then u2 will give me 2 squared, which gives me 4. Then u3 will be 3 squared, which gives me 9, right? And then of course this goes all the way until we reach like un, right? Which is the general case, right? That's why we call it the general term, because n can be anything. And then this will give me n squared, which is just n squared. So they want us to write the first 4 terms of the sequence. And how do we know it's a sequence? Because two things. The question here already says a sequence, and we know that we have a curly bracket, and we know that a sequence is just an ordered set of numbers. Right, so there's a set element over there. Right, so what are the first 4 terms of un? I actually wrote 3 already. Right, and then the 4th term, u4, will just be 4 squared, and that will give me 16. These are the first 4 terms of this ordered sequence. So next, is un an infinite sequence? Okay, so I have not mentioned about this previously, but we are just going to use this question over here as a way to teach you this concept. Okay, so the second sort of concept that you're going to learn, or the second term that you're going to learn, is this thing called an infinite sequence. So a sequence can have 2 types, right? So I'm just going to write here. A sequence, just to recap, is an ordered set of numbers. And an ordered set of numbers got 2 types. One is that it never ends, and one is that it ends at some value. So this one, the one that never ends, is what we call an infinite sequence, right? And then this one is called a finite sequence, right? You can think of it as finite means there are a finite number of terms, right? There's a fixed number of terms that you can count. But infinite means it's literally like never ending. So how do we know whether it's an infinite sequence? Let's look at the general trend of our terms. We see that the terms just keep increasing and increasing. And then the question here says that the n value goes on and on for all real values or real positive integer values. Right? You can see that n over here is a positive integer. Right? This symbol over here, the z, means it's an integer. Right? And then we put a plus sign to denote that it's a positive integer. So since it never ends, that means our terms in the sequence will just keep going on and on forever, perpetually. Right? So therefore, we know that this is definitely an infinite sequence. Right? And we know it's an infinite sequence because the sequence never ends, as n can practically take on any real positive integer value. Right? You can have n equals to 1000, n equals to 2000, so on and so forth. Right? Yeah, that's it. Now for the third part of the question over here, they say that the sum of the first n term is denoted by s, and this is actually linking us to the next concept, which is what we call a series. But you are still able to do this question because the question already defined for you what is Sn. This symbol over here basically means the sum of the first n terms. So if I have S1, means it's just U1 because it's just the sum of the first one. S2 would be U2 plus U1 because it's the sum of the first 2 terms, right? And then S3 would be U3 plus U2 plus U1, right, over here. And then last but not least, S4 will be U4 plus U3 plus U2 plus U1, right, the sum of the first one. So all in all, you can actually just use your answers above because over here you know that U1 is 1. Then this is just 4 plus 1, which is 5. This is just 9 plus 4 plus 1, which is 14 for S3. And then the last one will be just adding everything together, right? So 16 plus 9 plus 4 plus 1, which gives you a value of 30. Right, so this is the first question to actually see whether you understood the idea of what a sequence is. Okay, so just to recap, a sequence is just an ordered set of numbers. So when you have an ordered set of numbers, there's many things that you can calculate. And we learned in this video that a sequence has 2 types. It can be either a finite sequence or an infinite sequence where it never ends because the n, there's no cap to the n value, right? It can literally take on any positive real integer. So all in all, this is it for this question. If you have any other questions, let me know in the comments below. If not, move on to the next video where we'll talk about what exactly is a series, and I'll see you there.